So, without further ado, I will invite in our first speaker, Stanislav Stefanic, who will tell us how KiwiCom handles and boosts code base and stack in a fast-growing startup. Welcome.
Thanks. Cool. Good evening, everybody. Thanks for coming. We are also glad we are here. It took us only 5 hours from the airport. So pretty good. My name is Stanley. Do you listen to me? Like everybody is good? Okay. My name is Stanley. I am working at Kiwi.com as head of booking. Our responsibility is backend of order processing and managed by booking part. Today I will tell you something about us, but not about us, about startup which would grow up a lot in the last couple of years. And I will try to share with you something what we learned during this journey. And I hope you will take something from this talk what you will maybe use in your job, and it could save you a lot of time, energy, or maybe money. So, how it work? Done? Okay, perfect. So, let's start with a story. 6 years ago, one guy had a dream. He wanted to fly to Lisbon. So he searched a ticket, spent like 2 hours for searching flight tickets, and the best deal what he was able to get was $300 tickets. What was bad? That was a problem. Guys have like some limited budget for this trip. So he was searching for some other options. Not as a clever guy, he knew that in the last couple of years there was a lot of low-cost carriers which are flying within the Europe for really cheap prices. So he spent 2 days for searching some other alternatives, and after 2 days he did it. He found a way how to get to Lisbon for $80. 80 versus 300, much better. Guys was smart and thinking a lot about it, and knew that there must be a better way how to find it, not to spend 2 days of manual work, but there should be something what could find you these kind of tickets within a second. And indeed, he started taking it seriously, find a partner, and open Python tutorial and start coding it. They integrated like several airlines. They created some simple search engine, some order processing. New people were coming. They were able to get some investor to do it. So they get money, business was growing, they are coding a lot, just coding and ship something to production. And one day, really, they were able to do it. They created a website which was able to do something like this. Basically, combine the airlines and find the best combination for a really cheap price. So everything was good, new bookings were coming, business was growing, they were integrating more and more airlines, more and more content, new and new features. Everything was super shiny, guys was like this. But as always, fun has just begun. And after 1 year, or probably 1 year, it was 2014, what happened? One shiny day, one Russian partner wrote us an email with a message that, hey guys, you have really good prices. How were you able to do it? And we was, good, like you are super good, hell yeah. You are doing good stuff, thanks. Everything was shiny. After few other days, another partner wrote us basically the same message. That started to being suspicious, so we started digging into it, and we found something we weren't really happy with it. What happened? Periodic task, which was updating currency rates, stopped working. Why? Because websites we were using disappeared. API started to returning 404. And when it happened, 1 month and a half ago. In that time, Russian ruble was at 90. In our database, it was 60. So kind of a big issue. Company almost bankrupt. But we managed to survive somehow, and we learned 2 important things. One thing is, when there is something what seems to be too good to be true, then it's probably not the true. Find a bug, start finding something, because actually sales was never that high than these days. It was rapid growth, nobody expected it, nobody knew why, but everybody was happy. So when it's something really too bad or too good, start finding an issue. And another thing what we learned, we agreed that we need to have much better visibility into our system. And what we needed is basically monitoring, alerting, and logs. You can, or you should monitor several stuff. You should monitor CPU, and like basic host stuff and server stuff, memory usage, network, and stuff like this. But you should also start taking care of uptime. Uptime of your services and also services you are using and rely on. For example, API for changing for currency rates. There is a lot of tools you can use for it. And also make sure that each of your services you're using in production will have some ping endpoint, or ideally status check endpoint, not just ping, which is just dummy endpoint which is returning 200, but real status check, which is using some of your resources you rely on, for example, database or some third-party APIs or some caching and stuff. Put this into the monitoring. This is an example, for example, of Pingdom, how it looks like. And monitor your website, your APIs, everything what this business is rely on. Another kind of monitoring is error reporting and error tracking. Basically, every time when some traceback happens in your code, or some API stop working, some connection error, you want to see it immediately. You don't want to just find it after 2 months in some logs that something bad happened. You want to see it as soon as possible. Again, there is a lot of tools you can use. We are using, for example, Sentry. Sentry can do regression of this error. You can see how often these errors occurring, how many times they occur, how many user affected, traceback, and a lot of good stuff which will help you with debugging, and you realize that something is wrong immediately. When we have this tool, there is another monitoring, which is called application performance monitoring. And this could be useful, for example, in case time is running like further. We are now in year 2015, and you just sign off a new partner which will double your traffic. And customers start complaining that, hey guys, your managed by booking loading is really slow. Okay, why slow? You don't know. It could be anything. Basically, managed by booking from backend point of view is a super expensive call, which is taking information from 30 tables in database, 5 APIs, another database, caching, some computing and stuff. What could be wrong? In these times, it could be anything. It could be some bad index in database on some table which was not that important in old days, but now when this table grew up, it could be really critical, and the load of the response time of your API could be 1,000 times higher. In that case, this could really help you. With APM, you can see how your how traffic is going. What is your latency distribution, how many errors you're getting, etc., etc. And you can, especially, this is pretty helpful in debugging like something like manage my booking call, where you can see what happens and how long it took. And here you can see also, for example, traceback when it's ended with error, or SQL query which took so long, etc., etc. So this is another very useful feature in monitoring. And when you have this in place, then there is another pretty useful thing, is some logs management, but something smart. A lot of people have some logs, like I hope everybody have logs, but a lot of people have logs somewhere dumped on the server, just stored in text files. And imagine the situation that customer is complaining that he bought the flight 2 months ago, and on the search result page he saw different price that we charge him, and he realized now after 2 months. Your first reaction is, yeah, sure, why not? I check logs. But after a few hours checking logs and realizing that logs were shipped somewhere to permanent storage because log rotation, and some logs got lost, you realize that you spent 2 or 3 hours with digging into something, and you basically got nothing. You are in the moment when you are pretty understaffed, you need to deliver a lot of feature, you are pushing the business up, and the last thing what you want is to spend 3 hours of your development time to searching and grabbing some text files and stuff like this. So use some smart tool for logs. There are again several alternatives. It could be self-hosted or hosted. Here is an example how it can look like. What is the super important? It's easy in UI, it's easy to search. Here you will just write the query what you want to search for, and you will get the logs. And basically you can delegate a lot of this to QA, and you don't have to waste time of your developers. And last but not least is some incident management tool, and basically connect all these tools, all these monitorings, and to alerting, and have some tool which alert you as soon as possible. Why? Because when something will break up at the midnight, it's pretty nice that you will see it in every graph and every tool at 10 a.m. when you will come to work, but you lose 10 hours of profit, and you can bankrupt during this time. So you need something what will alert you immediately, call you during the night, and get somebody from your team to fix it immediately. We are using, for example, PagerDuty. It will call you, it will send you push notification, SMS, whatever. That's first part of the story of KiwiCom. And now we will go to the present time, to 2018, and what changed after, like in last 5 years. The number of lines of code went from basically 0 to 2.5 million. Number of repositories is more than 450. You have 150 Python developers which are taking care of this whole machinery. You have huge responsibility for people, for business and stuff. Numbers are totally different. You are selling 30K tickets. You are basically moving one small city from one part of the world to another part of the world every day. Imagine that something like fuck up with rubble would happen now and we will not realize it in few hours. It would be disaster for the company. It's totally something different. And of course you need to push and push and push more feature, more projects, basically hundreds every quarter. What is super growth cost? It's generated huge technical debt. Basically, there is complete lack of tests. Main vision and main top priority was to deliver as soon as possible MVP, 80% working solutions, but deliver it as a AP. Code has a huge complexity because when you are delivering and coding really fast, you are making real ugly solutions, real hacks, and it's super hard to work with it. It's basically unreadable in many cases, and it's super hard to maintain and add a new feature. What could help you with it, or what you should start doing with it? Basically two things. First one is adopt some best practices. I will not tell you what kind of best practices, it doesn't really matter, of course PEP 8 and stuff like this, but you should agree with team. What is much more important is make sure that everybody will follow it. After you agreed on best practices, you need to do two things: clean the old code and make sure that new code will follow the best practices and nobody will start ignoring it. Here there are several tools which can help you with this. They are called Black, Koala, or Pilot, and we will talk about them in a minute. And the second thing you need to start to do is refactoring, and basically start refactoring all the time. You have two options. If you have time and you can afford rewriting it completely, then rewrite it. Push your clients to use new APIs in much better, and it saves a lot of time. But in many cases, you don't have this effort, and you will not be able to afford it, so you need to refactor it. There's, again, tools which can help you with this. Pilot or SonarQube. How many of you know about these tools, Black, Koala, or SonarQube? Cool. What is it doing? Black is uncompromising code formatter. Black will push you to follow the rules. There is no exceptions. You will hate it at the beginning, but in the end you will love it. Why? Because when you are sharing code base with another 10 developers and everybody have some different habits, writing code in different ways, formatting code in different ways, then when you are reading it and trying to understand it, you spend so many time just with trying to read it. That's it. Black will push the formatting and everything will look the same. Basically, this is what Black will do with your code. There is no exceptions how you will write if, how you will write whatever. There is strict rules, and when you get used to it, it's pretty useful and it's pretty nice to read. Another super cool tool is Koala. Koala provides you unified command line interface for writing and fixing all your code. And this is the interface. It's for all languages, but it's written in Python. And actual part of the Koala, which are doing really like some analysis in the code, are working some extensions or plugins into this interface. They are called bears, and there are plenty of them. I listed several of them. For example, import sorbeer, like beer for finding you unused code, and etc. After you run the Koala as command line script, it will tell you what is wrong and how to fix it. That this import shouldn't be there, it should be there, etc., etc. And the last tool is basically platform, SonarQube, and it can help you with refactoring a lot. especially when you don't know where to start. SonarQube is able to detect your bugs, code smell vulnerabilities, printing you some nice reports, analyze your code and tell you how big is your technical depth, test coverage, and can show you the complexity of a particular function and stuff like this. Just run it in the code base, you will see immediately what functions should be refactored as first. Cool. We have tools, we know what we want to do, but how we will ensure that the 100 developer in your company will follow the rules and use these tools. Trust me that you shouldn't trust developer, that they will do it. They will definitely not, you need something else. And we adopted a modern development technique, which is called continuous integration, where you can enforce it. How it works, basically continuous integration main goal is to reduce the integration hell during the development, because a lot of companies working in some kind of sprints and they are releasing only in particular specified date. They have a 3-week sprint, they are coding, and at the release day they will try to merge everything and deploy. That's hell. It worked for one time of the companies, but for most companies it's much better to small micro releases several times a day. So continuous integration is philosophy which pushing your developers to ship code several times a day. Basically every atomic unit would make sense, every functionality should be shipped and released basically immediately. Commit and release. So when developer codes something, he will push it into the shared repository, basically Git or what we are using, and it triggers the pipeline. Pipeline is very important part of it. Pipeline is some chain of jobs which are running some scripts. And these scripts or this pipeline should have definitely 2 main parts. The first one is build. The second one are tests, unit and integration tests, and you can add it this static analysis tool I was talking about a few minutes ago, like Koala, SonarQube, or Black. And you are sure that every commit which is going to be on production pass the test, and you are happy that your code base is like in some normal way as you want to have it. In case the pipeline failed, then it's obvious, developer should fix it. In case it's passed, then it's going to next stage, what should be review, acceptance test, deploy to staging, or QA testing, etc., and then release. There is a lot of integration tool you can use, especially for running pipelines. Well known is Jenkins because it was the first one, but we are using GitLab CI. And this is how our pipeline in our main booking repo looks like. The first part is some linting and building. There's Black, Koala, and build. The second parts are tests. Then SonarQube, just to be sure that we are not adding something with higher complexity as we already have. And then release. And currently we are able to release and deploy on production just by 1 click. Basically you just click this button and you are releasing to production. Canary production or workers. We have a small gadget to do it. It's called Crane. In case your stack is similar as ours, it means that you are using GitLab CI and your application is running on Docker and it's orchestrated by Rancher. Feel free to download it or submit the issue or fix the issue or just use it. It's pretty comfortable to release to production just with 1 click from GitLab. What next? Next step for us should be continuous delivery and continuous development. Basically, they are doing the same, almost everything automatically. There is just one big difference from business point of view. In continuous delivery, there should be also manual step, like somebody who will tell, like, now we are going to release. But it could be, for example, product manager. It shouldn't be developer. Or not shouldn't be, but it doesn't have to be developer. In continuous development, everything is fully automatic. You will push the commit when the pipeline test, everything is accepted. It is slowly deployed to production. without anything. Both are good. It depends what you are doing, and if you have some blocker or you need to coordinate your releases with other teams, etc. And it's just up to you to decide. Our vision is to adopt the delivery next Q and deployment probably next year. So that's it from my side. Three main things. Don't be scared to try to make a bug, to make a mistake, fail if it's necessary, but don't forget to learn. Every time you will fuck up something, you need to learn from it, you need to prevent the fuck up, you need to build in your company, in your team, environment which is pretty honest and pretty blameless, and every mistake should be your advantage. Like, you will never do it again. Another thing is use tools, use libraries, use everything what is accessible for your development. Don't try to build everything under the hood. Let other people be the best in their area, and you should focus on your business and be the best in your business. Don't be scared of tools and everything. It's pretty useful. And the last thing is use the common sense and the beer view during doing anything. I'm not sure how many of you are working on some startup or some your projects, but in general, in every part of the project or company or startup, you need something different. In case the guy from the beginning who had the dream started doing continuous delivery at the beginning, we would be probably not here, and Kiwi would not exist. And that's it from my side. Thanks for your attention.
Thank you. Thank you so much. Quick note, guys, you see, we got ourselves in a bit difficult situation with this venue. Yeah, it's a bit noisy around, so just keep the mic like that and just speak up, right? Okay, that would be great. That will help to hear you and to understand the presentation. This is a note for future speakers as well. So thank you so much, guys. Any questions? Okay.
Thank you for speech. As I see, you had a huge code base, so there is a question about which version of Python do you use?
It depends. As you saw, we have a lot of repositories. Everything new is, of course, pushed to Python 3, but there are still some legacy code in Python 2. But we are working hard to move it to Python 3 because, as you know, it will be a huge problem next year.
And so there is another question about it. How hard was the merge from the Python 2 to Python 3?
Sorry again?
Is there how do you merge from Python 2 to Python 3?
How we are adopting Python 3 and Python 2 code? Basically, we are doing two things. We are trying to rewrite what is possible. We're creating new services with a totally different framework in Python 3, and we are rewriting part of the functionality to new APIs. This is the one thing, easier one with this. Another thing is to use the tools which are available. There is a 6, there is Future and Futurize, Modernize, which can help you with it. Of course, you need to be careful about it. There are some itchy stuff like division by zero, strings bytes, and stuff like this. And try it. Is everything is okay? Then use it.
We will talk later about it.
Sure.
Okay. Any questions? Are you stretching yourself? Do you have a question?
Okay. Yeah. Thank you for your talk. I have two small questions. First one about your continuous integration and about your GitLab CI pipeline specifically. When you run SonarQube, is it just analyzing and I don't know, later you see those reports, or if some percentage of acceptability is don't
yes,
reached, it fails.
No, and in current situation, the SonarQube is not something what is like breaking or sorry. Yeah, it is not mandatory. It is there in pipeline just because we want to see when somebody is trying to add something what is increasing the complexity of the code or introducing some vulnerability or something like this. It will send us a warning. We will check it. And in case it's really necessary to do it like this, because sometimes it is, like you are pushing from business point of view, then it is accepted, but I hope it didn't happen last few months. It didn't, cool.
Okay,
we're really pushing guys. We have a rule, basically, when you touch the ugly code, because you have to, and you would increase this complexity. Sorry, bro, you need to refactor it.
Okay, thanks. And the second small question. I saw you run smoke tests on production.
That was just an example. We didn't.
Oh.
This is what is coming next. We are planning to do it hopefully next year. Yeah, we'll do it.
Okay. So maybe it's for later.
Yeah, sure.
Okay. Thanks.
A question for the future. Okay.
Thank you for your talk. I wanted to ask, I just saw my PyCheck in your test section in continuous integration, but you didn't mention it at all. Yeah,
I think Tin has it in presentation, so I need to let something also for Tin. Tin is the next speaker. He will mention MyPy.
okay.
The next presentation. Okay, any more questions? Are we done? Okay, I think we're done. Thank you so much.